Okay, so hey John, hope all is well. So when we were working today, we started with a z-score. So we had our curve and we started and decided we wanted to know the probability that z is less than 1.52, right? So we found 1 and 1.52, and we found this area underneath by looking at the z chart. This is just a review. So we went to 1.52 and 0.9357. So this was 0.9357. So we found out that that's what that equaled, because that's what that shaded area is equal to. Okay, so the next few problems that you're going to have to do involve kind of doing the opposite of what we were doing before. Okay, so the problem might ask you what, so they say z is less than z star, and that equals, say, 0.95. Okay, so you notice in this, like up here, we didn't know what the answer was, what the probability was, but they gave us what z to look at, and that's what we found on the graph. So in this question, what they're doing is that they're giving us the probability, but we need to find out what number on the graph that's going to be. So you can go ahead and make a chart like you did before, and then what you have to do is you approximately say, okay, so that's going to be like 95% of the curve shaded, and so you still use the z-table, but what you do instead is you look at it and you look through these numbers, these probability numbers, instead of the z numbers on your first step. So if you're looking through the z, you're like, okay, 0.9495, 0.9505. So let's just do this 9505. And then you look over and you find out what z that equals. So that equals 1.65. So we know that this is going to be 1.65. And then that's what the z star is. So if you see, it kind of just went a little bit backwards from what we had before. So instead of us trying to find out what the shaded area is, they tell you what the shaded area is, and then you go in the table, find it in the body of the table, and then find the associated z-score, and then you know that that's what this line is, that's what the number is that you normally would have started with, like we did today. So that's just in general how you do it. And then what they're also going to do is they're going to do examples where they ask you to, say, find the top 10% or the top 5.75% or something like that. And they're going to give you a type of data, kind of like we were talking about before, where, so like say we do the average minutes played that we talked about this afternoon. So mu equals 20. We said standard deviation equals 5. So remember, on average, a basketball player plays 20 minutes a game with a standard deviation of 5, because some play more, some play less. So they could ask you a question that's like, they want to ask about elite basketball players, right? Like, how many minutes do they play? And so they say, tell me, what do the top 10% of basketball players play based on this standard distribution? And so you can think about that. You're like, okay, so I'm going to draw my curve. Got 20 here, 25, 15, blah, 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 old news to you. And we're saying we want to know the top 10. So it's just like this echelon up here, this wing, right? And if we know that that's 10%, then we know that this 2 is going to be 1 minus 0.1.9, right? So when we look back at our table, we remember that we're going to look for the shaded area below. So if we shade this, we're like, okay, we need to look up 0.9 in the table. Okay, so just like we did on the normal one, we go back, we look in the table for 0.9, and it looks like this 0.8997 is going to be the closest. So we go over, that's 1.28. So we know this is 1.28 as a z, but remember again, we have to standardize or unstandardize. So remember that z equals x minus mu over sigma. Okay, so now we know that we have 1.28 equals, we want to find out what that equals in minutes for basketball players, minus 20 over 5. And then it's just normal algebra, right? So you just times by 5 to get that away, and then whatever, so that's 0, 4, something like 640, I don't know, don't trust my math, and then equals x minus 20, add 20, add 20, and you get 26.4 equals x. So we can say that the top 10% of men's basketball players play 26.4 minutes or more per game. Okay, so I know that those were both like super quick, but you can go back and look at those steps again, and that should be able to help you through. You'll have to combine those a little bit with what we talked about earlier today, because by the time you get to the end, it's going to be a combination of standardizing, going from probability to z, then standardizing based on information, and then probably doing some of those tweener ones that we were doing earlier that were a little bit more challenging. And so I can't guarantee that's going to be easy, but I know that you have those skills that you can do, and you can get at least the majority of those points. Okay, so I just want to wish you good luck, and I know that you can do this. You're a really smart dude, so just get it done. Okay, have a good night. Bye.